You're a teacher and you want to engage your students. You want to provide experiences so that the students learn and that they understand and that they can apply the information. You want to go beyond just telling. Today we're going to follow the Danielson Framework and look at a case study and how teachers can do just that. If you're a K-6 teacher or a science teacher in middle level or even high school or even college, there's some concepts that students don't get right away and that they need to investigate and understand, and that it's better if teachers provide that scaffolding and guiding that discovery and checking to see if they understand. They don't just use the words, don't just repeat what you've told them without thinking it through, but can demonstrate an understanding. And the Danielson Framework has many tips and ideas about what teachers should do in that regard. But sometimes it's better just to look at a case study and then see if you can generalize from this case study to other content you might teach. So science teachers are responsible for teaching about how the solar system works and how Earth has its seasons. And so you could start a class by asking the question, what causes the seasons? Why is it winter and cold? And why is it in the summer it's warm? And so you could just ask that question, wait for hands to go up, and then you could try to get the right answer. Or what you could do is say, I'm going to extend this question for the next 5 minutes, and I'd like you to pair up. And in each pair, I'm going to give you 2 spheres. And I want you, with these spheres, to demonstrate the sun and the earth, and show me and show each other as I circulate around and see what you're doing, the difference between summer and winter. And you'll walk around and hopefully you'll have the sun be the center everywhere. And sometimes folks will do this. And of course you can correct them gently and quietly in their small groups as you walk around and ask the question, now wait a minute, what is in the center of the solar system? I know it feels like there's a sunrise and a sunset, but really what's going on? And then you should see them say, oh, what's going on is this is turning. That's what's causing the sunrise and the sunset. But does that have anything to do with the seasons? And so then you circulate around and you set the stage for the pairs to ask each other's questions. And you could prompt and say, what's the difference between summer and winter? One is cold and one is warm. What would that do? How would that impact what's physically going on? And what you're going to find is a lot of students will show that in summertime, the earth is closer, and in wintertime, it's farther away. And so as you circulate around, you can prompt students and actually let them know that in fact, that's not the case. I will give you that information that we're actually closer in the northern hemisphere to the sun by not much, but by a little bit in the wintertime. And so it's not the distance between the sun and earth that causes it to be hotter and causes the seasons. And so you might ask, show me what a year looks like. And so they're not spinning, they're making this go all the way around. And then you might say, now show me the poles. And that's when you might have them take a pen and mark the North Pole and the South Pole and say, now show me how the Earth goes around. And so what you'll have to then indicate is, you know that the Earth is on an axis and it's actually tilted. So giving you that information, what way do you think it's tilted? And show me summer and winter. And then you can walk around and circulate to all the different groups and get them so that their Earth is on a tilted axis. Get them having it going around so that they kinesthetically are getting an understanding of the way the solar system works. And then have them show you what is summer and what is winter. And you might have to scaffold it even further and say, where is the sun at noon in the summertime? And so it's lunchtime and it's noon, and the kids will point straight up. So you'd say, well, depict that. Where are we in the northern hemisphere in Pittsburgh, if that's where you are? Or if you're closer to the equator, point to where you are and say, show me how the sun would be directly above the Earth in the summertime, and then show me in the wintertime at noon that the fact that the sun is closer to the horizon. How would that look? And so you walk around and I'll let the students experiment to see what would that look like. And you might then have to replace the tennis ball with a flashlight and see what does it look like when the Earth is on its axis and it's pointed right at where we are in Pittsburgh, if that's where you are, noon, and have it go around. And when it's over here in December, where is the light pointed? On the southern hemisphere. And so then you might say, so what have you concluded? Tell me what your observations are. And the students are going to say, well, we've noticed that the sun is direct when it's summertime, and it's shining below the equator in the wintertime. And so the fact that direct sunlight is what makes it warmer and what causes the seasons, and indirect sunlight makes it cooler. And so that's a part of students' experiences when they're out in the sun and they feel it directly bearing right down on them. And then what you want to do is give them a tablet paper and a pen and say, now draw what you mean by direct and indirect by putting the sun, putting the Earth on an axis, and putting a dot on where we are and showing that depicted in the summertime and showing that depicted in the wintertime. And then we share that back to the group, both this physical model and then the representational picture that you drew, and have people explain in their own words their understanding of what this means. And so you want them to lead them to say that it's not how close the Earth is to the sun that causes things to get warmer or hotter. It's the fact that when sun rays are going across more of the atmosphere and aren't directly hitting its target, things are much, much cooler. And that's how much we depend on the sun to warm the Earth and to cause the seasons. And the reason why the poles are always cold, because they never are pointed directly at the sun. They are always pointed at an angle away, the poles are, whereas everything in between, of course, the equator is the hottest because that's where the sun is basically hitting it directly no matter what way the Earth is tilted. And so you could tease that out from conversations. It depends on what students notice, what their observations, and then how you'll fill in the blanks. But are you ever telling them outright that what causes the seasons? No, you've asked the questions. You've provided the tools for them to observe and test their own ideas. And you've asked them to write it down so that we can see it and verify that, in fact, the words that they say and the things that they've portrayed here, they can also demonstrate their understanding through using these symbolic representations. The Danielson techniques and things that model suggests that you do, those are embedded all throughout that lesson as I showed. And so it's important to refer to the Danielson Framework for ideas about how you can stimulate your teaching so you're not just telling, but you're guiding discovery, you're getting your students engaged, you're having them work in teams so that they're coaching and teaching each other, you're walking around and you're providing individualized feedback, and you're guiding the group to make their own observations. And in doing so, they're engaged, they're thinking, and they're able to apply the concepts and demonstrate understanding. I wish you all the best of luck as you apply guided discovery and the other techniques that Danielson Framework suggests that you use as you move forward in your good teaching.